Hello, in this video I'll be talking about scatter plots and trend lines. The definition of a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. It's similar to graphing from a T-chart because we don't have an equation, we just have information or data that you might get in a science experiment or something like that. In this case, I have a chart here that shows the altitude in meters and the temperature in degrees Fahrenheit, and it's based on a plane. So when you're flying in a plane, they took the altitude measurements and took temperature measurements, and this is what they came up with. We don't have an equation, we just have information, and so we're making a scatter plot. Here's a scatter plot of the data. As you can see, it's not quite linear, but there does seem to be some sort of correlation here, and we'll talk more about what that means later. On this next slide, we'll talk about finding a trend line and writing its equation. In this case, we're talking about the weight of a panda based on its age. So here's its age in months and its weight in pounds, and I've plotted the ordered pairs on this graph here. As you can see, there's looks like a correlation here, and we can make a trend line that fits the data. Now, to make a trend line that fits the data, there's you can use a graphing calculator to give you an exact trend line, and there's pieces of information that the calculator will use to figure out what the best trend line is. But for our uses, we just want to get something close, and so we're just going to look for something that has about the same amount of dots on above the line as below the line. So we're just going to estimate it right now. So let's see what we got. We'll do this and that. Okay. So looks like it's going to start at 0. So probably something close to that would be our trend line. And what we can use a trend line to do is to make a guess about other ages. So we can guess, although we don't have the weight of a panda or this particular panda at 7 months, we could guess based on the trend line what its weight is. You can use, when you guess about something in between two values that you know, it's called interpolation. And so I could interpolate that at 7 months the weight will be about, let me get a dot here. At 7 months I could guess that the weight's going to be about 30 pounds, right about here. You can also use a trend line to extrapolate a guess as to what its weight would be maybe later on. And so maybe in 14 months I might guess that its weight is somewhere up here around 62 pounds, something like that. So if you're making a guess or an estimate based on the trend line in between 2 points, it's called interpolation, and outside the points would be extrapolation. So anything up here would be an extrapolation, anything in here would be interpolation. So now if we wanted to come up with the equation of the trend line, we just need to find 2 points. And now that I think about it, its weight at an age of 0 probably wouldn't be 0, so this would probably move over here slightly, and this might move over here slightly, so something like that. Now we just need to pick 2 points on this grid. They don't have to be exact, but I'm trying to find points where they intersect the grid lines, so maybe something like right here would be a good point. And then so that would be what, 8 comma 35. Oops. So at 8:35, and another point down here, maybe 7.5 looks pretty good. That's down here. And so we just use that to find the slope. Remember to find the slope here. We have m equals y2 minus y1 over x2 minus x1. So in this case, we could do 35 minus 7.5, which is going to be, let's see, take away 10, you got 25, 27.5 over 8 minus 2, which is 6. So here we have the slope, and we could reduce that, I'm sure. 7, 8, 9, 12, 14. We could probably figure out a decimal for that, or we could just have it at 275 over 60 and reduce that by 5. Let's see, 20, 40, 55 over 12, something like that. And then we need to use point slope form. So y minus y1 equals m times x minus x1, and that will give us y minus 35 equals 55 over 12 times x minus 8. So here's the equation of this trend line in point slope form. If we wanted to put it in slope intercept form, we could solve for y. We could also put it in standard form if we wanted, but this is fine for now. And again, we can use this equation to interpolate and extrapolate. Now, some scatter plots don't seem to have any correlation at all, so we would call this no correlation if there doesn't seem to be any order to the points. This graph, we would call this positive correlation, meaning as the age increases, the weight also increases. This graph we did first here has a negative correlation because as the altitude increases, the temperature decreased. Okay, so when it looks like that, that's negative. Positive, no correlation whatsoever. Now the last thing I want to talk about is causal relationships. Causation is when a change in one quantity causes a change in a second quantity. A correlation between quantities does not always imply causation. Let me give you two examples. Let's say you're making bread, and in making bread the recipe calls for flour. So there is a correlation between the loaves of bread you make and the amount of flour you use. And the more loaves of bread you make causes you to use more flour. So the loaves of bread and flour used is a causal relationship. Okay. Now let's think of a city, and in that city we have mailboxes and firefighters. Certainly there would be a positive correlation between the number of firefighters in a city and the number of mailboxes, because the more people, the more houses, the more firefighters you're going to need to put out fires in that area. So that there's a positive correlation there. However, if you build more mailboxes, that doesn't mean you're automatically going to get more firefighters. So that's not a causal relationship, but it is a positive correlation. And that's it for this video. Thanks for watching.